It's about the costs of greenhouse gas emission reduction. The week before about options to do so, technical options. Today I'm going to talk about policy instruments. Go ahead.
Are you going to talk about the course work at all at some point today?
Yeah, this afternoon.
Okay, great, thank you.
To take away that concern, right, I'm going to mark to the curve.
What does that mean?
That I'm not going to mark in absolute sense. So I'm going to mark you guys against one another rather than against my expectations.
Okay.
What does that mean explicitly?
Got a better chance of getting a better mark, so relative.
So,
That scares me. That really scares me.
Actually, it shouldn't scare you. In this case.
Yeah, obviously it's
Yeah,
still
but yes,
better.
that's somewhat
We're still getting no sleep anyway.
Yeah.
The word needs some late submissions, yes, in the sense of 3 in the morning.
No, I was at 2 minutes past midnight, I remember.
Yeah,
It's just a half hour before midnight. It's quite rare.
Now we're going to talk about that in the afternoon. Marking to the curve means that the best one is actually I'm going to score absolutely. And the ones that are doing, I'm not allowed to tell you guys what I've given you so far, right? That's why I need to be a bit cagey. So the worst performer in the group is going to get around 40, the best performer in the group is going to get around 65. And then there's also somebody in the group who actually knows how to do this for reasons that are not quite clear to me.
Oh my gosh.
Right.
Who is that?
It's probably the exchange.
Yeah, we need to hunt them down. Not in that sense.
Well, that kind of is,
No, like
That
get
got
them
started
to teach us.
So there were a couple of non-submissions. That's trivial. There was one who got a 90, and then the rest of you are between 40 and 60.
Yeah. So we won't know what we've got until the end of the course.
I ran out of time. I was to send you guys an email with some feedback, but
Oh, okay, great.
literally.
Could we get that
that's
before
that's
the
really good.
second?
Yeah.
Like by the end of this afternoon or whatever.
I had hoped to send out that email before class, but
Oh, that's great.
that didn't work.
Yeah, thank you.
Okay. Okay. So I'm going to talk about policy instruments. This is one of the hardest classes to teach because I'm going to build very strongly on what we did last semester. You may recall that we had 2 classes on policy instruments. So essentially I'm going to take that, add some material that is specific to climate policy, but at the same time I'm going to do a brief recap of what we've done before. So it's hard for me in the sense that I have to accelerate and decelerate and accelerate and decelerate all the time. It may also be exhausting for you guys. And the overarching question is very simple. The government has a target for its greenhouse gases, its greenhouse gas emissions, and the question is then what should the government do to achieve these goals? Direct regulation is the most common form of environmental regulation, still very popular, still widely used. It works if you have a small number of homogeneous sources of emissions. If not, direct regulation is probably not very effective and certainly very expensive. Because of that reason, it's just not suitable for a problem like greenhouse gas emission reduction, which has a large amount of very diverse sources. Taxes, subsidies and tradable permits are much more suitable for diverse sources of emissions. Essentially what you do there is you, in case of taxes and tradable permits, you punish people for emitting. With subsidies you reward people for not emitting, but you leave it to the companies, to the households to sort out how they're going to do it. You're not going to prescribe what sort of technology they should use or how they should use the technology. You just give them an incentive to reduce emissions. And if they don't want to reduce emissions, but pay the financial penalty as that comes from non-compliance, that is their business. You leave them essentially that freedom. Tradable permits, I talked about last term as well. Essentially you have an overall target, you sort of allocate that target to the different polluters, and then you let them sort it out amongst themselves who is going to do the pollution. So you give them an initial allocation, and then you let them figure out who is going to do what. You sort of give the initial responsibility, initial allocation, but the final allocation is for the market to decide rather than for the regulator. A crucial bit in tradable permits is how you start the system. And this is particularly important for climate because it is an international problem. So what you do in the tradable permit setting is the government decides on a total cap, cuts that cap into little pieces, and then those little pieces somehow need to move from the government to agents in the economy. There's various ways of doing so. The most popular one is grandparenting, where essentially you give away the permits for free, and you give away the permits in proportion to past emissions in the recent past, preferably. Politically, this is easy because no money changes hands. The government creates a property right, does not take the property right for itself, gives it away to the previous implicit owners of these property rights. So it does not upset the status quo. It is an easy way out. One of the problems with grandparenting is that you essentially start with a zero price for your emission permits because you give it away for free. An alternative is that the government sells the permits to the highest bidder in an auction. The advantage is that you start the market with a price so everybody knows what these things are worth. That reduces market uncertainty and helps establish a market and smooth the initial stages of the market. An advantage for the government is that this generates a lot of revenue with which they can do nice things. The disadvantage is, of course, that it generates a lot of revenue. That is, somebody has to give the government a lot of money. So that is both an advantage and a disadvantage depending on what's your perspective on this. Auction permits are very similar to taxes, in the sense that there's a uniform price for emissions, and in the sense that there's money flowing from the emitters to the government. The difference between tradable permits, auction tradable permits and carbon taxes is that the permit price changes much more rapidly over time than a carbon tax ever can. Taxes typically change once a year or less frequent, whereas of course permit prices can change by the minute, essentially. The The reason that we want to put a price on our emissions is because it's an externality. If we recall Pigou, then we would realize that in order to restore efficiency in the market, what you need to do is that the polluter needs to pay and the victim needs to receive the compensation. There are two parts to a Pigou tax. Often forgotten. The government often pretends that it's the victim and therefore worthy of receiving Pigou taxes. That is not what economic theory says. So, in order to restore or to honor this part of Pigouvian taxation, what you would do ideally is to give the permits for emissions to those who suffer from climate change. And then, if Shell wants to emit a lot, then it would automatically compensate those who suffer a lot, because it would need to buy the right to emit from those people. Two problems with this. One is we need to identify who suffers most from climatic change, and we need to not just establish a rank order, but also establish a cardinal order, like you suffer 10% more than somebody else, which will be very controversial, very complicated. And another thing that we'll talk about in the coming weeks is that most of the impacts of climate change will occur outside the jurisdiction of any country. It's a global externality, and a lot of the more severe damages will actually fall on developing countries. So if this is the rule that you're going to use, then there will be a large transfer from Britain to Bangladesh, which is one of the most vulnerable countries to climate, one of the countries most vulnerable to climate change. You may think that's a good idea, right? It's a form of development aid. You may also see it as a form of compensation for past wrongs, but it also is a political no-flyer that we would transfer large sums of money unconditionally to poor countries. A simpler way of allocating the permits in an international context is to give everybody an equal per capita share of the total cap. You can do that nationally as well as internationally. Internationally, this has a foundation in international law. The atmosphere is the common property of humankind. And essentially putting CO2 in the atmosphere and other greenhouse gases in the atmosphere is degrading, in a way, our common property. So there is a basis in international law to do it this way. It's relatively easy, much easier to count people than to say you are more vulnerable than somebody else, right? Some people think it's fair. It's not necessarily fair. A lot of decisions were made before climate policy, before we realized that climate change was a problem, and by just allocating, by not acknowledging that, you're essentially punishing people for past decisions, and past decisions may go back a long way. For instance, if you live in Norway, you need a lot of energy to heat your house in winter, much more than when you live in Spain. And by saying, well, everybody has an equal right to use energy, which is essentially what you do, is that you're punishing the people who live in Norway for living in Norway. And those may be decisions that were made by their distant ancestors, not decisions that they made themselves. Fairness is not necessarily guaranteed here. It depends very strongly on what you mean by fair. The political non-starter for per capita allocations is that, again, like with the victims, it would generate large transfers from those who emit most, which are the rich people in the world, to everybody else, right? So it's an academic discussion more than a political one, or a politically feasible solution. Last term I did talk about the Coase Theorem, where I gave the example of a saxophone player versus somebody living next door, not enjoying the saxophone playing that much. And what we established there is that you can do the social cost benefit analysis, then you would end up where the green line crosses the brown line. That is what a social cost benefit analysis would tell you. Where the optimal quantity is Q and the optimal price is P. We investigated a situation where there was a right to silence, and then we found that money would flow from the saxophone player to the neighbor, but they would actually agree on a quantity Q or a price P. And we also looked at the situation where there was a right to make as much noise as you wanted, and then there would be money flowing from the neighbor to the saxophone player, but they would again agree on a quantity Q or a price P. That's the Coase Theorem. The Coase Theorem essentially, in a way, separates efficiency, the final market allocation, and equity, that is the initial distribution of property rights. And the Coase Theorem immediately applies also to tradable permits, and says that regardless of how you allocate the permits initially, provided that the market is efficient and all agents are rational, in the strict sense, the market will find the same allocation. And the initial allocation of permits determines who pays what, who carries the biggest bill, and the final allocation determines who does what, who actually does the emission reduction. And that immediately carries over to tradable permits. I talked at length last semester about cost effectiveness. Don't need to go through that again. And what we established then was that market-based instruments are cost-effective as every polluter faces the same subsidy or permit price at the margin. This is also stuff from last term, and we're going to expand it now. If you use a tax as your way of reducing emissions, then you actually don't know what will happen to those emissions. In order to predict that, you need to know everybody's marginal abatement cost curve, which typically the regulator does not know. So if you use a system of carbon taxes, then you don't know for sure what will happen to emissions. You do know what will happen to marginal costs, because the change in marginal cost is set by the carbon tax. Simple as that. So as a regulator, you know that. With tradable permits, the situation is the other way around. If we disregard illegal emissions for the moment, then with a system of tradable permits, you know exactly how much emissions there will be, because that is the cap that you have set. At the same time, you don't know, unless you know the marginal abatement cost of everybody, what the permit price will be. So the economic consequences are unpredictable, the environmental consequences are certain. With tradable permits and with taxation, it's the exact opposite. You know the economic implications, but you don't know the environmental implications with certainty. This is actually a lead into choosing between taxes and tradable permits. Using these two facts, we can actually make a choice which of the two is better. And that is known as the Wiseman Theorem. Wiseman hasn't won the Nobel Prize, but I think we can add the word yet there. And part of that is because of what I'm now going to show you. So, again, social cost-benefit analysis. Here are the marginal damages of emissions. Here are the marginal costs of emission. Yes. So if we push emissions down, the marginal costs go up, right? So the quantity here is the quantity of emissions, not the quantity of emission reduction. Now suppose, okay, and then we want to have a quantity Q or a price P. Now suppose that the government is uncertain about what it would really cost to reduce emissions, or rather the government makes a mistake and thinks that the costs of emission reduction are actually are actually higher than they really are. So the government gives in to lobbyists who claim that it's going to be terribly expensive to reduce greenhouse gases. So this is the real cost, but this is what the government thinks the costs are. So in that case, the government would regulate the amount of Q prime rather than Q star, if it goes for tradable permits, quantity instrument. So it would under-regulate. It would, because it thinks that costs of emission reduction are higher than they really are, it would sort of go for a more lenient climate policy and would pick Q prime rather than Q star as its quantity. However, if it goes for a price instrument, for a tax, then the government would over-regulate. Because still the optimal regulation is where the red curve hits the green curve, which is at a higher price. So it would set a price that is higher than it should be. P prime is higher than P star. So if the government makes a mistake, there is a difference in regulation depending on whether you use tradable permits or taxes. In one case you over-regulate, in the other case you under-regulate. Now the government makes a mistake, so there is a welfare loss. So we want to be here. In fact, we end up here. So we have under-regulation. So what we have is that we have additional damages of this amount. This is the additional damage we do to the environment. At the same time, we have lower compliance costs to this magnitude, and the difference is the blue triangle, which is welfare loss. That is the cost of under-regulation, and this cost falls on the environment. Ditto if we go for a tax, and there's also a welfare loss. We go for overregulation, so there is an environmental benefit to this that is equal to this area, but there is a compliance cost to this which is greater, that is equal to this area, and the difference between the two is here denoted in pink, and that is the amount, that's the welfare loss of overregulation, and this welfare loss falls on the emitters rather than on the environment. Now, in this picture, the blue triangle is exactly equal to the pink triangle in size. But that follows from the relative slopes of the green and the brown curve. If the green curve is steeper, if marginal damages increase more rapidly with higher emissions, then the following happens. Now I should do it right. This is the original situation. Now we make the green curve steeper. That means that the amount of overregulation shrinks. The amount of underregulation due to tradable permits shrinks. Whereas the amount of overregulation due to taxation grows. And that means that the blue triangle shrinks and the pink triangle grows. And now, if this is the situation, then making a mistake in assuming what the marginal costs of emission reduction are is going to be costly if you use taxation, and it's going to be not nearly as costly if you use tradable permits. The opposite happens if the green curve becomes shallower. Then the distance between Q star and Q prime grows. The distance between P prime and P star shrinks. The welfare loss due to underregulation through tradable permits grows, and the welfare loss due to overregulation in the case of taxation shrinks. And in this case, if the green curve is shallow relative to the brown curve, marginal damage do not vary much with the amount of emissions relative to how the costs of emission reduction vary with your choice of emissions. In that case, you would want to go for tradable permits. In that case, you would want to go for taxes, because the cost of a mistake is small, whereas the cost of a mistake with tradable permits is large. So in the 1974 paper of Wiseman, he does this much more generally, but with the exact same result. And essentially what he showed then was that if the marginal damage cost curve is less steep than the marginal abatement cost curve, then mistakes with price instruments, that's taxes, are less costly than mistakes with quantity instruments, tradable permits. And vice versa, if the marginal damage cost curve is steep relative to the marginal abatement cost curve, then mistakes with quantity instruments, tradable permits, are less costly than our mistakes with price instruments, that is taxes. That's the Wiseman Theorem. Now this actually gives us, this is just the most general way of phrasing it. This actually gives some guidance for climate policy as well. The question is, if we vary our emissions a little bit, what does that do to the impacts of climate change? And what does that do to the cost of emission reduction? That is the question we need to answer. Well, climate is a stock pollutant. Climate change depends on the emissions of all countries across the world. It depends on the emissions over long periods of time. So changing our emissions in 1 year in one jurisdiction will not affect climate change a lot. So the green curve is shallow, it must be shallow. I mean, Britain reduces its emissions in 2016 by a little bit more, and that's not going to affect climate change by a whole lot. So it will also not affect the impacts of climate change by a whole lot. So the green curve is actually very, very shallow. Whereas if we go for a 5% emission reduction rather than a 1% emission reduction, climate doesn't care, but the cost will be a whole lot higher in the UK, right? So the brown curve is actually relatively steep. The green curve is very, very shallow. So that means that if you're dealing with a large international long-term pollutant like carbon dioxide, then your best option is to go for taxation rather than tradable permits. Now, this method was somewhat lost on our dear leaders, and the instrument of choice is tradable permits rather than taxation. The reasons for that is basically political. If you look at this, the international treaties on climate policy, then they all sort of like have some sort of global budget in mind for greenhouse gas emissions over the long term, and then it's sort of natural to start allocating them to individual countries. That seemed easier to the negotiators than an internationally harmonized carbon tax. This is not something that anybody wants to contemplate. Also within the European Union, it is relatively easy to agree on a common policy and common targets. Whereas notions of tax harmonization across the EU are still a taboo subject to even start thinking about, typically. So politically, people went for tradable permits. See that my slide is slightly outdated. It used to be that through the Marrakesh Accords and the Kyoto Protocol, there was emissions trade within a group of rich countries in the OECD. There was project-based emissions trade called joint implementation between the first and the second world, and there was similar project-based trading going on between the third and the third world. Then within the EU, there is the EU ETS, which is a tradable permit system. So that immediately means there's 4 markets for tradable permits. And if you have 4 markets, then of course you have 4 prices, whereas the criterion for cost effectiveness says that we should have 1 price rather than 4. As I said, this slide is outdated because there's also a system of tradable permits in the northeast of the US, RGGI. It's 5 markets, 5 prices. There's since last year there's a market of tradable permits in California. That makes 6, right? Probably later this year, South Korea will introduce a market that makes 7. China is talking about doing this and is running a few pilots already, and that makes 8. And one thing I forgot as well, that the EU actually has a separate market for aviation emissions relative to all other emissions. So that makes, if I count correctly, 9 markets with 9 prices. So the criterion for cost effectiveness, one problem, one price, is immediately violated by the fact that they've created a plethora of markets rather than a single one. Let's look a little bit closer at the EU ETS, because that is most relevant for where we are. EU ETS, I think, started in 2005. It does essentially how I describe the theory. That is, there's a total cap on emissions. They're cut up into individual emissions for a ton, for a right to emit a ton of CO2. And those were initially grandfathered, that is, given away to the major emitters. Initially, it covered about 45% of total emissions in Europe. Nowadays, it covers about 60% of emissions. There's still a lot of going back and forth about whether to include aviation, how to include aviation, whether to include Australia. They had a deal, but then the Australian elections intervened, so that is off again. As I said, the permits were grandfathered. Essentially, what the European Union did here is that it gave away billions upon billions of euros to companies. So I said that the atmosphere is the common property of humankind, you and me. And the EU just expropriated that property right and said, it's us, and it's free for us to give away, and they gave it away to companies. These things are worth a lot of money, as I said, billions of euros per year, and essentially this is equal to a capital subsidy. Essentially, we've boosted the capital balance of a lot of companies. Some companies indeed use these grandparenting as their major source of finance. They don't borrow money from banks, they don't have a lot of equity, but their major asset is the right to emit. Indeed, some companies have bought old factories in Romania where the only thing valuable in the factory was the right to emit CO2. The machinery in the buildings and the workers were a lot of rubbish, but the CO2 rights were actually worth a lot of money. So this is economically significant. Gradually, very gradually phasing out grandparenting, and more emission rights are being auctioned. And the plan is, but we know how EU plans go, is to complete that transition by the year 2020. Emission rights can be banked, but not borrowed. That is, if this year, rather this trading period, you want to reduce emissions further than you have emission allocations for, then you can use those emission permits in the future. They do not expire. There's no best before date on emission permits. You can't do it the other way around. You can't say, I'm going to reduce emissions less in 2015 and then I'm going to promise to do more in 2020. That is not allowed. Or rather, I should say in 2021. That is not allowed. In 2020 it is not. So you can sort of like push them to the future, but you cannot promise to do more in the future and do less now. That is between trading periods. Within trading periods, there's full banking and borrowing. So within 2008 and 2012, or 2013 to 2020, you can freely shift these tradable permits through time. So essentially, the right is to emit any time between 2013 and 2020. The reason for that is the natural variability of emissions. So energy use varies quite a bit with weather, with all sorts of things, oil prices, international conflict and all that sort of stuff. Just emissions go up and down every year by a little bit. So if you have a hard cap on emissions for 2015, say, and it happens that during the summer you have to fight a minor war, and then November turns out to be really, really cold, then it may be that come Christmas you've run out of permits. And you don't want to shut down the country for Christmas, you don't want to turn up all the Christmas lights because you've run out of permits. That would mean revolution, right? So one way of solving that, there's two ways of solving that. One way of solving that is to say, well, emission rights are not for 1 year, because emissions in any 1 year are unpredictable, but they're for a longer period of time. And if 2015 turns out to be very cold, then chances are that 2016 turns out to be much warmer in winter, because that is what weather variability is like. So that is one way of smoothing the shock to the economy. There's always an escape clause in emission rights or in emission permits, and that is if you emit but you don't have a permit, you get a fine. In the EU ETS, the fines are in the order of €1,000 per ton of CO2. Whereas the price of these things is around €5 per ton of CO2. So the fines are very substantial, but if push comes to shove, you can sort of like tie it over the period between Christmas and New Year. Skip this point. Emissions trade is midstream. What does that mean? But essentially, there's always a question, who should have permits to emit? And there's one way of doing that is called upstream. That is, everybody who digs fossil fuels out of the ground or imports fossil fuels into the European Union should have permits. That's upstream. The problem with that is that there's only a handful of companies that do so, so you would immediately create issues with market power. You could also do it downstream. That is, everybody who is ultimately responsible for emitting carbon dioxide should have a permit. That is, everybody should have a carbon account next to their bank account. The problem there is complexity, because now you're talking about 500 million people in the EU that should have permits. And of course, there's issues with, there's still a substantial fraction of the population that doesn't have a bank account, so how could they ever manage a carbon account? There's issues with literacy, there's issues with vulnerable people, there's issues with elderly people, there's issues with the uneducated who would not be able to comprehend all this. Therefore the EU went for midstream, which is that everybody who burns large quantities of fossil fuels should have permits, and then presumably pass on the cost to the consumers downstream. There are and were substantial problems with the EU ETS. The initial allocation back in 2005 of the permits was not done by the European Commission but rather by the member states. So as I said, the EU ETS covers about 50% of emissions. The other 50% are essentially unregulated. And within that 50%, Germany, the UK, France all had to give permits to their companies. What they did, predictably, was that they played a game of beggar thy neighbor. So you had sort of like this buffer of 50% unregulated emissions, and what every country did was it dipped into those things and said, I'm going to allocate a little bit more to my companies. I'm going to give my companies more emission permits than they really need. And then they can sell to the rest of Europe and they have a competitive advantage. They have an additional stream of income. Didn't work because everybody played this game. So there was just a complete oversupply of permits initially. Which explains, when this was discovered, explains this price drop. Right? This was a spectacular one. This was predicted. I was in the room when this was told to the officials of the European Commission. This is what's going to happen, and they said, fuck you, we're going to do it anyway. And they learned their lessons. The European Commission has now taken over the initial allocation, and this particular problem is gone. There's other problems. To paraphrase Lenin, property is theft, right? As soon as you create a property right, somebody will try and steal it. These things are not traded over the counter, right? They are traded electronically. There's no piece of paper or anything that is exchanging hands. It's all the electrons. Or hacked. To suspend trade for a while. Again, something was fairly predictable that somebody would try this. I mean, there's billions of euros floating around in this system. So if you can hack into these computers and run away with a bit, that's good for your bank account, right? Didn't. That happened, right? There was carousel fraud going on. Carousel fraud is essentially, again, this was predicted to the European Commission, this is what's going to happen. It used to be the case that in some countries you had to pay VAT on your tradable permits, and in other countries you didn't. So some smart people bought permits in countries where there's no VAT, sold them in countries where there is VAT, collected the VAT, and ran away to the Caribbean before the taxman would come and collect their VAT from them. It's a bit unclear how much money was really stolen this way. They uncovered about 300 million, but that's probably only 10% or so from the total, and some people in sort of safe countries are laughing their heads off of the stupidity of the European officials, right? There's other things going on. Tradable permits are essentially a license to emit. You get that license from the government, and that means that there needs to be somebody in the government who's paying attention to how much you're emitting and whether you're really doing what you're supposed to be doing. Romania had an issue there. It's a happy story. The civil servant who was monitoring the emissions got pregnant, went on maternity leave, and wasn't replaced. And for about a year, Romanian emissions were unmonitored. Nobody was paying attention. So the Romanian companies, the Romanian emitters could do whatever they wanted, right? For some reason, the United Nations suspended Romania from the United Nations Framework Convention, but the European Union did not follow through, and the Romanians are still in this system. Which leads me to the final thing, and then I'll shut up. And that is the whole issue of monitoring and enforcement. Within the EU ETS, permits are seller beware. There's two systems of liability in trade. One is buyer beware. If you go to the supermarket, you buy a bunch of oranges. As soon as you have paid, as soon as you walk out of the supermarket, it's your problem. So if you discover that half of your oranges are rotten, then that's your problem. Buyer beware, right? That's why you should inspect fruit before you pay for it. There's also systems of seller beware. You buy a second-hand car, you discover that something is wrong with it. Within 6 weeks, you can take it back to the seller. If you get a new house built and it turns out 4 years down the road that the foundations are rotten, you can go back to the builder and say, this is your problem. The seller is liable for the quality of the product they sell you. Tradable permits work with seller liability, which means that if a UK company buys a permit from an Italian company, and it turns out that that Italian company did not reduce its emissions but sold its permits nonetheless, then the UK company reports this to the Environment Agency, which enforces the rules in the UK, and at that moment the UK company is off the hook. They bought this in good faith. They reported the problem as soon as they discovered it. They are fine, they're in the clear. The Environment Agency then calls up its Italian counterpart and said, one of your companies did something naughty. And the Italian authorities at that point will put down, they'll say, thank you very much, they'll put down the phone and go back to sleep. Because the system is seller liability, enforcement of emission trading rules is as strong as the legal system in the weakest country in the EU. So I mentioned Italy, which for a long time had a convicted fraudster as its prime minister and has a legal system that is completely sclerotic, right? It's not good for anything. That may be the weakest case. It may be Greece, right? You know that the Greeks don't think anything about falsifying their GDP in order to qualify for the euro, so why would they not falsify their emissions if they think they can make a buck out of that? It may be Cyprus, maybe Romania. In both countries we know that organized crime is in the government. We don't know, right? But we do know that not all legal systems in Europe are as strong as, say, the legal system in Sweden. And that means that the eventual, the ultimate enforcement of British emissions policy is done in Cyprus, in Romania, in Greece, in Italy, not here. And that is a bit of a problem, I think. Some other people think that as well. The Americans were thinking for a long time of linking up their tradable permit systems to the European ones. And then they looked at the fine print of the law and they said, no way, we're going to go there. So, that's it for this morning. We'll see you guys in the afternoon when we're going to talk about the exercises. Go ahead.
I've got a few questions about the course in general. I should have asked these a while ago. What resources should we be reading? Because obviously we've got your book, and then we've got like background papers, and then we've got all your tweets with those articles and stuff. What should we read to sort of succeed in the exam?
In order to pass the exam, to say go to the 69, if you understand the book, that's enough. Or the 2-star parts of the book. Right?
Yeah.
There's also the 3 stars for the masters and 4 stars for the PhD.
Yeah. Okay. And then in environmental, you and George were really clear about why people last year didn't get a first. I was just wondering what the grades for climate change were last year, and if there's an obvious reason why people didn't do well, or if people did really well.
I can't answer that
Yeah, that's
from
fine.
the top of my head.
Yeah, that's okay. Yeah.
I'll have a look.
Okay.
So next week is actually devoted to this sort of stuff.
Okay.
So if you recall the schedule, there's lectures, computer lab, and then 2 hours of discussion, exam preparation. So next week I will know the answer to this.
Okay, that's great. Thank you.
What exactly are the computer labs? What will we do?
Is that are those Excel tutorials?
Yeah.
Ah.
Oh, so that's to do with the course?
Yes.
Okay.
Oh, that's good.
Were we supposed to have that this week, or is it next?
Yeah, you guys all handed in something. So we're going to discuss that this afternoon.
Oh, right.
Right.
Okay?